Is 29th of November 2024. We will do a quick review on covariance metrics and how to prove row space A is orthogonal complement of null space A, and column space of A is orthogonal complement of null space A transpose, and also about orthogonally diagonalized and symmetric matrix and the square root of symmetric matrix. First, when you want to find and calculate covariance matrix, let's think with the real data. Let's say there is some data which is this row has A's and this row has, this is categorical data. 0 is man and woman is one, and this is universe P. Entrance here, then you can make 3 by number of people, which is M. Then you can find there will be another, this is data and this is mean data. Then you can minus each other. Then you could find sigma squared. How do you really usually find sigma squared? By xi minus x plus squared sigma over n minus 1. In matrix, it is same, but it is slightly different because you need to do matrix multiplication. When you do matrix multiplication, you can't square 3 by 20 matrix, so you multiply what is transpose and divide it with n minus 1. And it will be n divided by n. Then you can find matrix which is correspond to sigma square, which will be 3 by 3 matrix with covariance of H, sex, and H entrance. And here will be covariance of sex and H, sex and sex, and here will be covariance of sex and entrance here. What you should notice is this is symmetric matrix, which has, they are symmetric except orthogonal. So covariance matrix is symmetric matrix. Then there is some good property of symmetric matrix. For here, when you do symmetric, when you do decompose symmetric matrix, you usually do LU decomposition first and transpose U. So make LLT format, LLT or orthogonal complement format, or if there is PDP minus 1, then you can make PDP minus 1, which if it has some property, you should also organize some property in symmetric case. And in some case, P minus 1 equals to PT. So you can write it as PDPT. And next, you can divide it as P root D PT when it has good property. when it has very good property, you can write it as this. Then you can write it as P with P P. Then you can get square sigma square, which is correspond to sigma, it will be sigma. This will be sigma square, and this will be correspond to sigma. In this case, we also use that in case it can be splitted. So you should notice the condition. And also today, after I solved the problem, there are some different examples. So listen carefully. Project Y onto W is you can, when it is orthonormal, and with in some case you can split it as U multiply U transpose multiply Y, which is you can write it as U1 to UP, column of U1 to UP, and U transpose will be from row U1 to UP. Then you can write it in some format, and only Y will exist at the end. And for the proof of row space A orthogonal complement is null space A, and column space A's orthogonal complement is null space A's transpose. We can prove it by finding basis of row A and basis of null space A. Then we should check it is orthogonally complement. Then we can do dot product to check it. And for last problem was regarding is and it's also very important that when A is PDP minus 1, P is represent for size, and P is represent for angle, but we will see more carefully at next time. And last problem was about AX equals to 111 has no solution. AX equals to 010 has exactly one solution. In this case, then M will be 3, and we should find N and R. In this case, 111 has no solution, which means think about X. X will be N multiple 1, N by 1. Let's put some values in it. Like when N is 1, then there can be 100. If there's 100, 100, 100, then alpha, there can be some alpha. If 100, alpha 00 will have no solution. And 100, zero. That's 1, 0, 0. Alpha has exact solution. When the number of 4 free variable situation or number of 2 free variable situation. Okay, thank you for listening today.